Good evening, students. This is Manas Patnaik, your friend and tutor. And in today's one-shot video, we are going to be solving all the questions that had appeared in the engineering graphics paper from the University of Mumbai. And this is May 2022 session I'm talking about. All the solutions in one single video. There are as many as 7 problems with internal choices, but I'll solve all the problems for you. And a small piece of note for everybody who is watching this video right now. If you come from any university, from any state across India, you can send your question papers directly to me on this email ID. So please take a screenshot of this video right now. If you want your question papers solution, do send their PDFs to me on this email ID. And one more thing, ये वीडियो हिंदी में भी अवेलेबल है, उसका लिंक आपको नीचे डिस्क्रिप्शन में मिल जाएगा. पूरा सोल्यूशन हिंदी में भी है, ठीक है. तो टेंशन नहीं लेने का, दोनों भाषाओं में बताया. इंडिया नॉर्थ साउथ ईस्ट वेस्ट कहीं से भी हो. मेरे ख्याल में अगर हिंदी नहीं समझते तो अंग्रेजी समझ जाओगे, अंग्रेजी नहीं तो हिंदी समझ जाओ, ठीक है. इससे ज़्यादा भाषाएं मुझे नहीं आती हैं, तो मुझे माफ़ करें. ओके, ऑलराइट. I think it would be better if we can just start discussing all the questions with you very briefly, and then I'll let you know where you can find the PDF solution to this entire paper, right? आपके लिए PDF भी बना के रखा है भाई, टेंशन मत. Okay, so here it is. As you can see, this question paper has as many as 1, 2, 3 and 4 questions or 4 parts, let's say. Right, what you need to follow is the first angle method of projection. That means object is above HP and in front of VP. Wonderful. Maximum marks 60, and you can get 60 out of 60. And let me make one thing very clear. This is something that I have observed a lot of students experience. If they find it difficult to clear the paper in their first attempt, then it gets even more difficult in the second attempt and more difficult in the third attempt. So this is a sort of a compounding problem for the students. Please, I request all of you, please pay attention. ध्यान से engineering graphics को पढ़े. Focus on this subject very carefully, because this is not like other subjects where you can mug up things and vomit. Let me be very frank. You have to understand the question properly and make proper drawings. Okay, there is a lot of brain that you need to put into. Okay, whole lot of things has to be understood. You need to generate skills. उसके लिए मेहनत लगेगी, right? So don't ignore this subject. I have seen people drag this subject into their second year, third year, and 5 to 10 years back, when there was no rule for debarred, people actually finished their engineering, 4 year of engineering, and still they were giving their engineering graphics paper. There was one student who gave this engineering graphics paper. Even while he was working with some industry, they had no problem of him having any backlog as such. So don't fall into this trap. Okay, and if you want to learn in a very comprehensive manner, you can enroll in my course. The link is right there in the description under my guidance. If you want to schedule a one-on-one session with me, you can. A lot of students do so on a daily basis. Sir, yes, problem में difficulty है, थोड़ा बता दीजिए. One-on-one session I schedule with them. I solve their difficulty. Although there are recorded lectures, but some students want one-on-one attention. थोड़ा सा उनको help हो जाता है. I do it on a regular basis. So don't worry. Do not hesitate to ask questions. बिल्कुल घबराना नहीं है. Okay, if you have difficulty in any problem, send it to me. Schedule a session with me. No problem whatsoever. All right. So the first question has got 2 parts. Problem number 1 is from projection of lines. Second one is from these cycloids. Okay, so this is a relatively easier problem. Projection of line, it will take you around 5 to 10 minutes, not more. Let me tell you very honestly. If I'm a student, I'll choose this one. Okay, rather than choosing the problem on, this is not cycloid, this is involute. Okay, and here when you start analyzing the problem, you'll realize that in this case, the length of the string happens to be less than the circumference. Okay, and whenever you encounter such cases, either less than the circumference or more than the circumference, there is a problem with the construction. But don't worry, I'll provide a very good demonstration of that. Okay, so problem 1, part A is what I'll go for. Question number 2, again, it has got 2 parts. In part A, this is basically a problem from projection of solids, and it is very easy. You can see here the axis is making an angle of 30 degrees to the HP. I'll go for this one. I'll get 15 marks. Lock by 15 marks and move to the next problem. Question number 2, part B, is from the topic orthographic projection. This is also very easy, but again, this is going to take more time, maybe 20 to 25 minutes for an average student. I will not recommend this, although I provided the solution, don't worry. Question number 3 has got 2 parts again. In part A, this is from the topic isometric projection. Okay, again, this is going to take some time, maybe half an hour. If you are very skilled, still you will take around 15 to 20 minutes, but for an average student, it'll take around 25 to 30 minutes. Let me be very honest with you. And I mean, it is of 15 marks, so in order to fetch it, you need to put in your hard work. Question number 3, part B, is from the topic of projection of solids. Not that easy, let me be very honest with you. When I made the solution, even I got confused. Okay, but don't worry, I have provided the solution very comprehensive. To access the solution also, I'll let you know how you can access the PDF file. Question number 4, there is no internal choice. You have to attempt, and it can fetch you 20 marks. This is very, very important. Well, just taking a look at the question paper, it appears as if they put a lot of emphasis in topics such as orthographic projections. These 2 problems are from orthographic projections purely, and 1 problem is from isometric. So ortho and iso, these are the 2 topics which you should focus on. Okay, very, very honestly, let me tell you, if we just focus on these 2 topics, let me tell you, you can clear the paper very easily. 20 plus 15 is 35. I don't know what the passing marks out of 60 is. Please let me know in the comments. कितना चाहिए भाई 60 में पास होने के लिए? Okay, but don't don't just worry about the passing marks. Your preparation should be such that you should get 60 out of 60. Okay, considering the human error, I'm sure that if you come under my guidance, you will surely get 50 or more out of 60, right? Okay, so these were the questions. It's challenging. The last question is really challenging. It took me around 4 to 5 hours to create the entire solution, although the video is very short, 20-25 minutes, but the entire solution, animation, I also took the help of AutoCAD. I actually created a 3D version of this object in the AutoCAD's environment. It's a beautiful solution. Do have a look. And these videos take a lot of time and effort, so consider liking the video, sharing it with all your friends, and also subscribing to the channel, right? I really work a lot for all of you. Okay, so questions now have been discussed, and if you really want to enroll in my engineering drawing course, you surely can, right? The link is below in the description, and you can learn all of these things under my guidance. I have provided all the recorded videos both in English and Hindi. Does not matter which university of India you come from, all the topics from engineering graphics have been demonstrated in these videos very, very beautifully and accurately, both in English and Hindi. Don't worry. Secondly, there are PDF notes for each chapter. There are worksheets that you can attempt. There are MCQ problems, literally MCQ problems, computer based MCQ type problems also you can attempt. You can evaluate yourself. There are score will be released, what problems are there. Okay, let's come to the university wise content. In university wise content, you will see that I have provided 3 folders: SPPU, that is Pune University, Mumbai University, and JNTU Hyderabad. So I have put up the content of all of these 3 universities inside these folders. If you want to access the content of Mumbai University, just click on it. Okay, here, let me click on it once again. Go down, and here you are going to see PYQs. Okay, click on it. May 2022, click on it. Here is this PDF. I have kept it unlocked. Does not matter whether you have enrolled in my course on my application or not, you will be able to access this PDF. If you click on it, the entire solution will open. Okay, this is the solution, right? Here it is. The same PowerPoint file that I used to demonstrate all of these things. Here is the solution. All the solutions are there. Okay, all the problems, very beautiful solutions, everything very, very accurate. I'm sure you're going to appreciate it. Secondly, if you want to have a look at the syllabus, the syllabus also has been provided. Where is the syllabus? I don't know if I provided the syllabus or not. Anyways, don't worry. So this was about my application. The download link is in the description. Download the app, install it, and have a conversation with me directly. Okay, if you have, in case you have any doubts, right? So I think we can start with the solution of Mumbai University's engineering graphics paper. And here we go. So the first question in this question paper is from the chapter projection of lines. And we are going to always read the question twice. First, to take a feel of the problem description, and then we are going to extract data the second time we read it. Here we go. A line AB 65 mm long. That's a line AB 65 mm long. Has its end A. This is end A, let's say. 20 mm above HP, 20 mm above HP. 25 mm in front of VP. Assume my body to be the vertical plane, 25 mm from my body. End B, this end, is 40 mm above HP. So height from HP is 40. Very well. Then, and 65 mm in front of VP. My body is VP, 65 mm from my body. Draw the projections. Okay, that means the final front view, the final top view. That is A dash, B dash, and AB. Right? And show its inclinations with HP and VP. That means you need to work out the angle that the true length of the line makes with HP and VP. Essentially means theta and phi is what you need to work out. Once the drawing is made, these calculations can be done with the help of, or these measurements can be done with the help of a protractor. Very easy. Now let's read this question second time. There is a line AB 65 mm long. This happens to be the true length. Its end A is 20 mm above the HP. So any distance of a point with respect to HP is denoted by H. What is this? Distance from HP. Any distance with respect or from the VP is represented by D. Okay. Remember these two representations. So 20 mm is HA and 25 mm in front of VP is DA. Done. In the same fashion, end B is 40 mm above HP. Here it is. And 65 mm in front of VP. So DB is 65. So we have written down all the data. Let me take you to the next slide for the drawing. And here we go. What are you going to do now? Sir, there is a note which has been given in your question paper that use the first angle method of projection. That means the line we are talking about is in the first quadrant. Okay. So in the first quadrant, the line is composed of points. What are the end points? These are points. Okay, so this point is above HP and in front of VP. This point also above HP in front of VP. So use the logic. Whenever you're talking about first quadrant, there is this XY line, H above and D below. With H, there is a dash. With D, there is no dash. Use the simple concept. I am going to be using these two datas now. HA is 20, so 20 mm above. You've got a dash. And then DA is 25, so 25 mm below. No dash. It's this simple. I hope everybody, all of you can follow. Secondly, HB has been given as 40 and DB also has been given as 65. But how far is HP and DB going to be somewhere here, or are they going to be here? We don't know the exact location. So what we'll do is, for the time being, we are going to assume that HB is 40. Let's say 40 from the XY line. Okay. So point B dash could be anywhere along this line in the same fashion. So we've used this data. Secondly, DB is 65, distance from VP. So this distance 65, this is the distance from VP. Again, B dash could be anywhere. The exact location can be found out very easily. Don't worry. Until now, we have exhausted all of these four data. What's left? Sir, we are left with this true length. Now, true length can be implemented very easily. Make 2 points, very light points on your drawing sheet. Okay. And these 2 points are 65 mm away. What you need to do is you need to place the steel leg of your compass at one end and the pencil end over here, the other end. Okay. With this much at the radius. Now with AS center, you need to cut an arc and this is going to give you b1 dash. That's your true length, by the way. Okay, now again you have now used all the data. Now you can use this true length again with a as center, with same 65 mm as radius, cut an arc again, right? That's the true length. So basically what you have is this true length that is 65 millimeters, making an angle theta. You can do the measurement and work out theta. In the same fashion, this also, AB represents theta, not AB but AB2 represents true length, and it is making an angle of phi over here. So far so good, right? Now the problem has become very, very elementary. Focus on this point. Draw a vertical line this way. If this is b1 dash, this is going to be simply b1 with a b1 as the radius and with a as center. Rotate it in the clockwise direction until you reach here. This very point is your point B, and join B with A. That is your final top view. Similarly, produce a line starting from B2 until you reach the locus of A in front view. Here it is. This is going to be B2. This is B2 dash. Now with A dash, B2 dash as the radius, and with A dash as the center, rotate in the anti-clockwise sense until you reach here, or until you cut the locus of B in top view. This point corresponds to point B dash. Okay, join B dash with A dash. That's your final front view. If you want, you can connect these 2 points with the help of a straight line. Okay, let me show this to you. Here it is. It will be absolutely straight. Done. So that's your final drawing. And we also have been asked about the inclination. So I've written down all the inclinations: theta, phi, alpha, beta. This is theta, this is alpha, this is phi, and that's beta. And I've also written down the front view length, and that's the top view length. What is front view length? It is a dash b dash. Top view length is a b. So damn simple. Okay, I hope all of you have been able to follow how this question goes, right? And as far as pencil work is concerned, your final drawing should look something like this. This is going to be your pencil work. Question number 2, University of Mumbai. Here we go. So there happens to be a choice. 1A, either you can go with this problem on projection of line, or 1B. Now the easier option is projection of lines, obviously. Okay, let me read this. One end of an inelastic string 120 mm long is attached to the circumference of a circular disc of 50 mm diameter. The free end of the string is wound around the disc. Free end is wound around the disc. Disc is 50 mm in diameter, keeping the string always tight. Okay, draw the locus of the free end and name the curve. I mean, this is a simple problem, but it is time consuming. Given the choice, I'll go for projection of lines problem. Anyway, let's begin the construction. And before that, let's read the question once again and let's extract data. One end of an inelastic string 120 millimeter long, that is your length of the string, is attached to the circumference, okay, of a circular disc 50 mm diameter. Diameter of the disc is 50 mm. Done. Free end of the string is wound around the disc, keeping the string always tight. Draw the locus of the free end. The locus of the free end will eventually transition into an involute. Okay, whenever you solve questions or when you make drawings based on involute, please remember, always calculate pi d, which in this case pi into 150, the value is going to work out as 157.07. Please make a check, use a calculator. Then do a comparison whether the length of string is equal to pi d, whether the length of string is less than pi d, whether the length of string is greater than pi d. If you watch carefully, in our case, the length of string happens to be 120, whereas pi d has worked out as 157.07. Okay, whenever you do the construction, use 157 only. Okay, you cannot go for 0.07. You are a human being, not a machine, right? Your scale will let you mark 157 millimeters accurately and not 0.07. Okay, so in our case, the length of string is less than the circumference. Pi d is what? Circumference. So follow the construction steps. This is going to be fun. Here we go. If you want to take a screenshot right now, take it. This is going to be helpful. This is what we need to implement. Here we go. Start by making a circular disc look like a circle. Diameter is 50, so the radius is 25. That's 25, 25, 25, 25. Done. Very easy. Okay, sir. These are the 4 quarters. Okay. All of these quarter, or each of these quarter, can be divided into 3 more parts. So 3, 3, 3, 3 will make it 12 equal parts of the entire circle. Right? Please do the divisions like this: 1 dash, 2 dash, 3 dash. There is a specific reason why this particular point has been marked as 1 dash. I'll come to that. Don't worry. Now what? Now draw a straight line through the bottommost point of the circle like this. Sir, what is the length of this line? The length of this line is pi d. So as I told you, take it as approximately 157. Not to worry. Done. Can you do this? Yes, sir. Now divide this line into 12 equal parts. This is going to be the line division technique, which we have used quite a lot in engineering drawing. So start point. From here, draw a line randomly of any length. Let's say 120, 130, 140 millimeters. Okay. Now you can keep your manual scale over here, and at a regular intervals of 10 millimeters, you can keep on marking these points. I am making arcs. You just mark those points. Okay. If I start making points, it won't be visible to you on the screen. So I am going to put up arcs, 10 mm radii. Here we go. Here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Once you do the 12th mark, with the help of a mini drafter, connect this point and the end point of the line. Here we go. Now keep your drafter over here. Where is the red color? Keep your drafter, the long scale over here and the short scale over here, and then tighten the screw. Then move your drafter to this point. 11th point, draw a line. 10th point, draw a line. Keep on repeating the process until all the points have been exhausted. Now name them as 1, 2, 3, 4 until you reach 12. Done, sir. Now comes the very important point. What was your length of the string? One end of the string has to be fixed over here, sir. One end of the string has to be fixed here, while the other end is going to be somewhere here. We don't know the exact location. We do know the exact location. The length of the string, as far as the problem is concerned, is 120 millimeters. So keep your scale exactly, keep your 0 of your scale over here, and at a distance of 120 millimeters, mark a point. Please focus. Here it is. Okay, just beyond 9. Just beyond 9. Let me show this to you once again. Beyond 9, beyond 9, beyond 9, beyond 9. Okay, lovely. If you want to zoom in, here it is. Just beyond 9. Done, sir. Now what? Now if you watch, once you start wounding this string, this red color string, onto this circular disc, what will happen? Let's say this is 0. 0 to 1 will come in contact, and then the string will be like this. If you go ahead, 0 to 2 will come into contact, and the string will be absolutely tangential to 2 dash, or this spoke over here. If you go ahead, 0 to 3 along the periphery, and then the part of the string which is left, the free part, will be acting like a tangent to this spoke, isn't it? So what you need to do is, you need to create several tangents through all of these, or with respect to all of these spokes ending at 1 dash, 2 dash, 3 dash, 4 dash, and 5 dash, and so on. Okay, just like this initial position of the string is a tangent over here, here also you need to make a tangent. Again, this can be done very easily with the help of a mini drafter. Here also you need to make a tangent. Okay, everywhere 90 degrees. Here also tangent 90 degrees. How will you do that? Now keep your mini drafter over here like this, and then the short scale preferably along this spoke, 1 dash spoke, then the long scale will automatically give you the tangent. Okay, something like this, and you need to repeat this process for each and every spoke. Let me do this in one go. Here it is. Enjoy the show. Now, sir, why haven't you made tangents from 10 and 11, or 10 dash and 11 dash? The reason being very simple. Our free end, P happens to be the free end of the string. is going to end somewhere very close to 9, just beyond 9. So you don't have to go for 10, 11 and 12. Okay, the free end is going to end somewhere here, to be very, very precise, somewhere here. So you don't have to make tangents through 10 dash and 11. Even if you do, the evaluator does not give a damn. Okay, because that will not help you in the construction process. So now the step is very simple. Now once you have wound the string, this much portion of the string, okay, this much portion of the string, please, the portion left, the free length left is this much, from 1 to p. So now what you need to do is, you need to keep the steel end of your compass at 1 and the pencil end of your compass at p. Now with this much as the radius, and now with 1 dash as the center, cut an arc, and this is going to give you p1. Similarly, steel end of your rounder or compass at 2 and the pencil end of your compass at p. Now with 2 dash as the center, cut an arc again, this is going to give you p2. In the same fashion, you can mark the remaining points, p3, p4, p5, p6, p7, p8. And now the final point, this point 9 to p is going to be extremely small. If you want, I can zoom in. Here we go. Extremely small. And from 9 to p, with 9 dash as the center, you need to cut an arc. This is extremely small. Okay, that is going to give you p9. And yes, now you just need to join all the points in proper sequence. Okay, start from this point on the periphery of the circle, then on this tangent through 9 dash, and then on this p8, then p7. And once you join all of these points, this is going to give you a beautiful curve, popularly known as an involute. And if you want to see how the construction work looks like, how you need to dimension, this is how it would look. Name the curve, it's an involute, and you can see the construction work. It's very, very light. You need to keep it light. If you want to ensure that you get full marks for a drawing, make sure this is the standard, right? I hope this will help you understand the idea of creating an involute. So this is going to be the second question, and let's solve part 1 of that. Here we go. Let me zoom in. Okay. 15 marks. Either you can go for option A or part A or part B. It is your choice. I think the good option is part A. It's very simple, let me tell you, and this can be solved in the next 10 minutes. Very, very easy. A square prism, side of the base 30 mm and axis length 60 mm, is kept on the HP on a corner of its base, kept on the HP on a corner, not with respect to edge, but with respect to a corner. Please note that. Such that its axis makes an angle of 30 degrees to the HP. Axis making 30-degree angle with the horizontal plane. Draw the projections of the prism. Very well, let's read the question again and let's now extract data from it. So we are basically talking about a square prism. The base is 30 and the length of the axis is 60 millimeters. Here it is. Base, that's 30 millimeters, and this length over here, or you can also say the axis will be the center or top to the center bottom, and this is 60 millimeters. These are the dimensions. Resting on a corner on the HP, such that the axis makes 30 degrees angle with the horizontal plane. So theta, any angle made with the HP represented by theta. So theta axis is equal to 30 degrees. So these are all the data which have been given to us. Coming to the solution of the problem. This is basically a two-step problem. But the problem is, or the issue is, how are you going to create your step number 1? Okay, whether you're going to start with the front view or the top view, that is something that we have to decide first of all. The question that I'm going to ask you is, with which plane is the axis making an angle? Sir, the axis is making an angle with the horizontal plane. It has been mentioned very clearly. Therefore, our standard procedure says that if a solid's axis is making certain angle with the HP, then assume that that solid is resting with its base on the HP. Okay. In this case, the square prism or the axis of the square prism is making angle with the horizontal plane. Therefore, assume that the solid, that the square prism is resting with its base on HP. From where can you see the true shape now? Sir, the true shape can be seen from the top. Therefore, you have to begin by creating the top view. That is the first thing. Secondly, sir, the top view can be made in two ways. Either you can go with this top view, 30, 30, or you can also go with this top. Which one is the wiser option, correct option? Option 2 or option 1? In the problem, it has been clearly stated that when you incline the axis, one of the corner is in contact with the horizontal plane. Therefore, we are going to go with this. This is the case when corner in HP. Please remember, this is a very, very useful trick. If the corner is in HP, you have to start with this diagram. Okay, with this as the top view. If the edge, or if one of the edge is in HP, you have to start with this diagram as the top view. Okay, so with that being said, now let's kick off with the main solution. Please remember, the bottom four corners are 1, 2, 3, 4. The top four corners are A, B, C, D. Okay, here we go. Let's start. This is how you need to do this. Bottom four corners, 1, 2, 3, 4. Top four corners, A, B, C, D. Done. Now let's create the front view. Okay, so the bottom four corners, these are the bottom four corners. 1, then you've got 2, then you've got 3, then you've got 4. 4 is just behind 2, as you can see this. In the same fashion, you can now give it the height, that is 60 millimeters, and then you can create the top portion. Okay, A, B, C, D. Done. In the second step, we are going to incline the axis. The axis inclination is given by theta. Theta is the inclination of the axis with the horizontal plane. If the axis makes an angle theta, please remember, in such a case, the base is going to make an angle of 90 minus theta. So please note here, the axis is making an angle of 30 degree. Therefore, the base, if you plug in this value as 30 degrees, the base will be making an angle of 60 degrees. Okay, so what we'll do is, we'll make sure that the base is making an angle of 60 degrees. Then automatically, the axle will set itself at an angle of 30 degrees. Here we go. Take a look. This is the base. Yes, sir. This is the base. Right? That's the base. Now we are recreating the base from step 1 to step 2 in such a way that it is making an angle of 60 degrees. When you do that, automatically you'll realize that the axis will be making 30 degree angle. Now, with the help of a mini drafter, keep small scale of your mini drafter over here and the big scale over here. Okay, now this is going to be perpendicular. Draw lines like this. Can you do this? Very easy. Now make the top portion, right? If you watch carefully, this angle is 60 degrees. So this is where the axis is, just behind this edge. Which edge? Sir, this edge is actually B2. I'll reproduce this. This is going to automatically work out as 30 degrees. And that is exactly what has been given in the question. So the problem is almost done. Let us now view it from the top. Let me bring the projector lines in the downward direction and the lines from the left hand side. And wherever they intersect, I can locate the points. For example, along this line, I am going to have access to 4 points, A, 1, C, and 3. Let's say I want A. So this is the vertical for A. That's A. This is 1. Where is 1? This is 1. Then C. This is C. In the same fashion, you can find the remaining points. These is exactly what you will see. Okay. Now, it looks like a line from the front view, but it in fact is a square. The true shape is a square. But here you will see the apparent shape of that square. A squeezed square, which eventually looks like this. Right? Then you will see this edge. Then the 2B edge. Then the D4 edge. These are all visible. Okay. And that's simple. The edges which are not visible, which somehow got hidden, is 1, 2 and 1, 4. There is one more hidden edge which I have not marked. Okay, so I want all of you guys to comment in the to make a comment in the comment section down below as to which portion or which edge should be shown over here, which I have missed out. Please do it for me. Thank you. Question number 2 has 2 parts. Part A, we've cracked it very easily. Okay. Part B is a bit challenging, and that is based on orthographic projection. So let's take a look. Here we go. We've been given the pictorial view of an object, and we need to create the front and top view. On reading the problem, it looks very, very simple. Just take a look at this. you need to create the front view. This X mark is for the front, okay, as well as the top view. How can you do that? Let me take you to the final problem solution. Here we go. So here is the partition line above which you have the front view, and that's the top view. In the question, even in the question paper's note, we have been given that use the first angle method of projection. That means the object is above HP and in front of the VP. All right, here we go. So the first step is you need to work out the maximum length, width, and height. So the maximum length is 90, the maximum width is 60, and the maximum height is 40 plus 30 plus this much. That is 15. 40 plus 30 plus 15 is 85. Okay. So you need to make two boxes. From the front, you will see the length and the height, length and the height. And as I've just demonstrated, the length is 90 and the height is 85. Secondly, from the top, you will see the length and the width. The length and the width. Length again is 90 and width is 60. You can see this, right? Make sure you are using a very light pencil, preferably a 3H or a 4H pencil, because we are right now in the construction phase. And then you can overwrite also, don't worry, right? But use a light pencil. Anything lighter can be made darker. But going the either way, well, that's not good. Okay, now make the center line. Can you see the center line? Make it. Done. Sir, what about this point, this very point? How far below? Sir, this is, if you watch, this is 15 millimeter, the radius of this semicircle. So you can come down 15 millimeters. Done. So this is the center for the circle and the semicircle. And again, this is the center for the semicircle. We are going to make it accurately. Don't worry. What's next? In the next step, you need to create certain lines. So to the left and to the right. Please look. This circle is having a diameter pi. That means diameter is 15. So the radius is 7.5 to the left and to the right. 7.5 to the left and to the right. Then you've got these 2 points. Again, take a look. Radius is 15. So 15 to the left and 15 to the right. 15 to the left and 15 to the right. Agreed? Yes, sir. Okay. Please note down. We started off with 7.5, then 15 on either sides of this center line. Please note 7.5 and 15. Okay. Then this point is also essential, right? Because from here you can see a hidden line. The edge is not visible. Therefore, we are going to use a dashed line to represent its hidden feature. But how far is this point from the center line? That is something that you need to decide. Please note that this distance is 25, half of 50, out of which this much we already know is 15. So 25 minus 15 is going to give you this value. This value is going to be how much? 10. Let me rewrite this again. This is how much? 10. Out of which this is already 6. This is 6. So the one left, this much, is 4. Okay. Agreed? Yes, sir. So let me produce this very point. This distance we know is 4. So 4, and between these 2 points, the distance is, sir, 15. So 15 plus 4 is going to give you 19. So 19 to the left and 19 to the right. Can you do this? Yes, sir, we can. We started off with 7.5, then 15, then 19. Again, on either side, to the left as well as right. Sir, then you can straight away go for this point. Add 6 more. 19 plus 6 is going to give you 25. You look here, this particular point on both the sides. 22 to the left and 22 to the right. Just do it. 22 to the left and 22 to the right. And then you can go for this very point. Okay. With respect to this 19, add 6 more. So 25. 25 to the left and to the right. 25 to the left and 25 to the right. Done? Okay. Till now, we are absolutely clear, right? Okay. So far, what we've done is 7.5, 15, 19, 22, 25, 5 more, 30, 5 more to the left and 5 more to the right with respect to these two lines, right? Either you can go for 5 more, or you can with respect to the center, the distance is 30 on either side. Done, sir. Anything that we are left, please first of all take a screenshot of this. Okay, done. Now let me erase these things. Now what I need to do is, as far as this line is concerned, it is at a height of 40 from the base. You can make it. Then as far as this line is concerned, this is at a height of 10 from the base, so make it. Done. Now creating the front view becomes very easy, because these guidelines are going to help you both in the front and the top view. How? Take a look. So this is the center, and taking this as the center and the radius as 22, you can make this semicircle. Easy. At the same time, sir, this is the center and the diameter is 15. Radius is 7.5. Smaller circle. At the same time, this is the center and that's the circle. The radius is 15. So this radius is 15. Done. Circular profiles can be created rather easily. Now, please match the points. Yes, sir. Please match the points again. Okay. Left, right, left, right. Enjoy the process. Then go up by 10 millimeters. 10 millimeters. Done. This is the point. This is the point. These are the points. Join. Done. Then move towards left 5 millimeters. 5 to the right, and here 5 to the left. Done. Then move upwards by 30 millimeters. Upwards by 30 millimeters. And then straight away join with this semicircle. Join with the semicircle. Done. Done. The front view is done. Just a few hidden lines are left. We are going to work it out. Don't worry. Take a look at this now. Can you see this? Once again, how far below is this from the topmost periphery? This is 7 millimeters below. So from here, 7 millimeters downwards, you need to make a line, a hidden line, because that is not going to be visible. This is the hidden line I'm talking about. Okay, 7 mm below. And now you can make the construction, one horizontal and one vertical, through these 2 points. I hope you all can observe these things. Okay. Sir, what about this point? It's not visible. I mean, its distance, its exact location has not been given to us. Rather, it appears as if this slant face sort of has this point right at the center. Okay, the distance above is exactly equal to the distance below. Here also, the distance above is exactly equal to the distance below. I mean, this is the judgment that we can make. So what I will do is, we are going to just take the center of this very line and draw horizontal through it for both the profiles. Now, drop vertical construction lines through these 2 points like this. Okay, we'll do it later on. Don't worry. Don't worry. If you watch, this is a hidden portion, isn't it? Here also there is going to be a hidden portion, and we are going to draw it like this, right? So here, this is exactly, and you need to stop over here. I mean, the reference line which you just created, again hidden lines. Let me zoom in. Zoom in. Okay. By the way, this is 4 millimeters. This is 4 millimeters away to the left, 4 millimeters away to the right. Come down until you reach this midpoint. This midpoint horizontal reference. I think I should speak less. Okay. So far so good. Now what? And I have passed vertical lines, construction lines through them as well. Now what? Now, I think it's time to create the top view. For top view creation, you need certain lines. I mean, this is at a distance of, sir, this is 10 millimeters. So make it. At the same time, this line is at a distance of 20. So either from here you can mark 20 distance and make this line. And in the same fashion, there are going to be 2 more 20 and then 10, 10 this way. 20, 10, 10. Right? When you look at it from the top, this zigzag portion that you see, when you look at it from the top, will appear as a straight line like this. This portion that you see will appear like this. Okay, I hope that you are getting the point. This is how it would look. And as far as this edge is concerned, this is that edge, right? Okay, on either side of the center line. Now what? Now, look, how should we proceed? Okay, take a look. Here it is. Can you see this? This portion, this portion, this portion, this portion. Here it is. Let me make it properly. Can you see this portion now? Let me create it. Here it is. Okay, this is how you need to make it. I mean, basically what we've done is from here to the right, from here to the right, and then this way, and then this way to the left, and lock. Okay, whatever you do in the left of the center line, you need to repeat the same to the right. They are going to be exactly mirror images. In the same fashion, take a look now. This line, this line, this line, this line, this line, this line. Done. This is what you need to do. Your top view is almost created with a few more enhancements in the what is left. This portion is left. Okay, so we already have the guidelines. So you can see these are the guidelines. It is going to begin here and end here. Again, begin here and end here. Let me make it. Done. What else? Sir, the hidden feature. Circular profile. Drill throughout. This is how it would look. And this portion, this edge is not going to be visible from the top. And therefore, where does it start? Here, 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 and dashed lines for hidden features. Done. It is done. Okay, make sure that you put all the dimensions like this. It's finished now. If you can create a drawing of this standard, I'm sure you're going to get full marks. Make sure whenever your construction, I mean, making the construction of front and top views of any pictorial representation, you got to be confident, first of all. Okay, you have to believe in your skills, you have to believe in your abilities, right? All right. Question number 3, University of Mumbai. There are going to be 2 parts. So the maximum mark is 15. Here it is. Let me just zoom in. 15. So either you can go with this part A, which is a problem based on isometric drawings, or you can go with this problem on projection of solid, right? Both of these problems are at an equal difficulty level. It is going to take you around 15 to 25 minutes to be precise. And let's solve this one initially. Draw the isometric view of the given front and top views. So we have been given the front and top view of a machine component. Let's say we need to prepare the isometric view. That means the view where all the dimensions, length, width, and height can be seen in one single view. That's the isometric view. Okay, what is the other important characteristic about an isometric view? I mean, it is constructed in such a way that all the 3 axes, they happen to be at an equal angle with each other. They happen to be making an equal angle of 120 degrees with each other. Let's get going. This is going to be fun. Watch this right till the end. Here we go. The first thing is to decide where you are going to choose your length. Whether your length is going to be along this side or this side. Length, width, length, width. I am going to choose the length as 100 millimeters. I mean, I'm not choosing it as 100 millimeters. I'm going to choose length along this side, right? You can choose it here also. But if you choose the length as 100 millimeters over to this side, right hand side, the view appears slightly obstructed. Okay, the perspective is not that good. I would suggest you to pick the length as 100 millimeters over to this side, and then you can choose the width, which is equal to 50 millimeters over to this side, right? The final isometric drawing created is going to be very, very good looking, and really, you need to trust me on this, right? You can do it the other way around also, and you can make a comparison. It is your choice. So 50 width this side, 100 length this side. I think we should get going. Here it is. What is this? Sir, this is 100. What is this? This is 50. And gradually we'll be giving the height to all the points, to all the different elements in our drawing, right? This is a slightly tough question because there are as many as 1, 2, and 3 circular or semicircular profiles. Whenever you have to deal with such profiles, it involves a lot of construction and it takes a lot of time, right? Okay, so what we've just done, we have just created this. Now, what is this height? Sir, this is actually 12 millimeter. 12 units to be very precise. So give this some height, 12, both the sides. Done. Join them. Now, how much is this distance? Sir, if you take a careful look, this in totality, the length is 100. 100 minus 12 will give you 88. So this is going to be 88. So this is going to be 88. Again, you need to keep your drafter in such a way. You always need to move either in this fashion, or you have to move either in this fashion, or you have to move in the vertical direction, either up or down. Okay. Your movements are restricted along these set of axes. To and fro, to and fro, to and fro. That's it. Now what? We are right here. Here. What is this height? Please tell me, what is this height? Sir, this height is actually 50 minus 12. That is 38. So this is going to be 38. Okay, very well. What about this? How much is this height? Sir, this is 50. So this, please, I am marking out with different colors. This is going to be 50 and this red color is going to be 38. Done. Yes, sir. Now it's very simple. You can see this. Let me have okay. Please see it. This is what we'll be creating first of all. And this portion is left. Let me do this. Done. Okay. Now take a look. Red. Okay. And this is not red. This is purple. Okay. So how far back you need to go? Sir, we need to go back by a distance of 50 millimeters. So you can go 50 for this point also, for both the points, 50 and 50. And actually, there are actually 2 points over here. One at the top, one at the bottom. Although in the top view, you are going to, those 2 points are going to overlap each other. Okay. If I say this is 1 and this is 2, dash and 2 dash, this is going to be 1, 2. Okay. So there are essentially 2 points. You need to go back, traveling a distance of 50, 50, 50, 50. Again, 50, 50, 50. Done. Now finish it off. This way, this way, this way. Your basic structure is done. Now, you need to think about all the different profiles that we'll be creating. Take a look now. Take a look at this point. Where is this point? Here it is. This is the point I'm talking about. To the right. How far to the right do you need to go? How far to the right do you need to go? You need to make a calculation. Sir, this is going to be 12 plus 24, that is 36. 36 plus 12 will make it 48. So you need to go to the right by a distance of 48 millimeters. Done. Okay. Let me make this is okay. In the isometric, these are the 2 points I'm talking about. Right? I'll always be marking points and you can relate to them with this with this orthographic view. Now, this is the point I'm concerned about. What is the height? Sir, this height is 26 on both the sides. 26 from both the ends. Done. What about this distance? and this distance. Sir, this is actually 12 from both the ends. So 12 to the right and 12 to the left. Done? Yes, sir. Now, in between these 2 points, you have to create a sort of semicircular profile. So, but in isometric view, right? It should look like an isometric view. How do you do that? First of all, take a look now. You can connect these 2 points. You know very well that the gap between them is 24. Okay, and you can take the center also. This is the center. Once again, what is the radius of this semicircular profile? Sir, the diameter happens to be 24. Where did you see the diameter? So this is the diameter 24. So half of diameter is radius, that is going to be 12. So 12 to the right, 12 to the left, 12 above, 12 below, and from here we can construct the isometric view of the semicircle this way. Okay, please close it, this way, this way, this way. Now just focus on this shape. It looks like a rhombus. It will have a larger diagonal. This is also going to have a smaller diagonal. Focus on the endpoints of the smaller diagonal. Join it with the center of the opposite ends this way, then center of the opposite end, center of the opposite end. Let me make it. Okay, what we are now interested in are these 4 centers. Now first, what you need to do is pencil end of your compass and steel end of your compass, this much as the radius. Rotate in the anti-clockwise sense until you reach here. Then pencil end of your compass and steel end of your compass, rotate with respect to this center until you reach here. This is exactly how you need to make your semicircle. I have to remove the construction for some time. I'll bring it back, don't worry. Okay, now what's up? So we are essentially at this very point, green, green, green. How far back you need to go? Let me zoom in. How much is this depth? Sir, this is having a depth of 50 minus 10 minus 12. So 50 minus 10 is 40. 40 minus 12 is going to be 28. So this green point, from this green, you need to go back and travel a distance of 28. That is for sure. Let me apply 2 more points, red points. How far back you need to go? Please. Sir, this is 50. 50 minus 12 will give you 38. So 38, 38 from the red, 28, 28 from the green. And let me make 2 red points also. So remember, 38, 38 larger lines from red and 28, 28 from the greens, right? I'll be making this line also, don't worry. Okay, sir. Now what? Now you can make this. Sir, how do you make this without any references, without any guidelines? It's very simple. Let me tell you. Let me make the construction first of all. You know what you need to do is you need to keep your drafter aligned along this line. Have you done so? Tighten the screw. Done? Okay. How far back was this? Sir, this was 28 millimeters. 28 millimeters, centimeters, 28 units by the way. So you now need to travel a distance of 28 and mark a point. You just keep your scale over here, okay, aligned along this line, and then you need to get to this point, get it to this point. Simply make a point. Get your scale to this point. Don't even draw a line. Simply make a point. Get your scale to this point. Don't even draw a line. Simply make a point. In this fashion, you are going to have multiple points. And when you join all of these points in proper sequence, what you have is a beautiful curve, which happens to be the isometric view of the semicircle. Okay, I'm sure you all have understood how to create this circle at the back, the semicircle at the back, and that's the cheat code. Done. Now let's finish this up. This distance. Let me do this. Okay, that's 48. Close it down now. And now what we can do is down this way. Looks nice. And one more thing, I don't know whether you observed, there is a solid line. Okay, so that solid line will be represented in the isometric through this. Now it looks nice, very realistic. Okay, so far so good. Now what? Now there are essentially 2 points over here. One is at the front, one is at the back. In the front view, 1 dash and 2 dash. So one at the back is this point 2. I mean, this is a sort of a slant. You can make this very easily, and then one can be made over here. The distance between these 2 points is 10 millimeters. So at a distance of 10 millimeters, you can make another point and then again a slant. Come down and to the right hand side. Done. Okay. 5 more minutes to go, and we'll be done with this problem. You need to find the center point. This center point is for both the circular profile as well as the quarter circle profile. How do you locate this? Actually, the center is at a distance of 20 millimeters from here and 20 millimeters from here also, right? One dimension is missing, but it is 20 millimeters. So you can locate that center. It's very easy. Let me tell you. So what you can do is you can make 2 points, 20 millimeters, 20 millimeters. Then draw parallel lines with respect to this. Draw a parallel line. The intersection is going to give you the center. Very easy. Here it is. Now what you need to do is you need to observe the diameter. Sir, the diameter of this circle is 15. So the radius is going to be 7.5. So 7.5 this way, 7.5 this way, 7.5 this way, 7.5 this way. Right? Let me do this. Let me zoom in. 7.5, 7.5, 7.5, 7.5. Please make a point over here at a distance of 7.5 from the center. Here also. Okay. Now what? Now cover this. Again, the technique is very simple. Smaller diagonal, corner, join, join, smaller diagonals, corner, join, join this way. Let me do it in a much more civilized way. And these are the intersection points. So first of all, with this much as the radius, okay, with this as the center, let me do this. With this as the center and this much as the radius, construct. Then with this as the center and this much as the radius, do the construction, and you know the remaining steps. Okay, just make it. I'm going to remove this construction for some time now. Let me go ahead and do that. And now I am left with this semicircular profile, not semicircle, but quarter circle profile. By the way, how much is this? Sir, this is 40. What about this much? Sir, this also is 40. So 100 minus this, this was 48. 48 plus 12 is 60. 100 minus 60 will give you this as 40. 40. So, I mean, 20, 20. Now this is your playground and you need to construct your quarter circle. Extend 20, 20, 20, 20. Now the same stuff. Smaller diagonal. Okay. Centers of the opposite sides. Join with this and this. Done. You need to make only this much portion, right? So take this as the center and this much as the radius, anti-clockwise sense. Just do it. Here we go. Done. What about the quarter circle at the bottom? It is very easy. 12 mm below, make a point. Again 12 mm below, make a point. 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 And through all of these points, you don't need to make these lines. Okay, just mark these points. These points are going to act as guidelines for you to finally go ahead and make this curve like this. Watch it again. Watch it again. But this is how you need to do it. And that's the construction, total construction, right? Some teachers might get offended if you don't show the construction to them. So, and they are absolutely right. I agree with them. If you are taking so much pain to construct these circular and semicircular profiles, make sure the construction stays. Okay. But use a very, very light pencil, 3H or a 4H pencil for that purpose, right? If you do that, everything is going to look very, very decent. and sophisticated. Please take a look over here. This much portion of the semicircle profile is visible. This portion is not visible. So it has been kept in the 3H format, and this has been enhanced using an H pencil, made even a bit thicker. So make sure you use all of these hacks to make your drawing look good, and it should pop out. Eventually the use of different colors makes our drawing look, come alive, makes it pop out, right? It should look good to the edge, right? So that's the isometric view, and it was a challenging problem. In fact, there was a similar problem that I had done in my previous question paper series that was on Pune University. There also I had encountered a similar problem. Okay, the dimensions were different and the profile was also slightly different over here. I'm not able to recall, but yes, there was a similar problem that I had done. Anyway, I hope this problem has helped you understand the idea of creating an isometric drawing, and if you've got any doubts, write them down in the comment section below. Question number 3, part B. This is based on projection of solids. I want all of you to focus your attention, and I have got a jugadu sort of a demonstration for all of you so that we can get going with the solution of the problem. Okay, do watch this video entirely. Here we go. So we are talking about a pentagonal pyramid, 40 mm edge of the base, and axis height is 70 millimeters, resting on one of the corners of the base. How many corners are there? Sir, there are as many as, let me show this to you, 5 corners. You can see this 1, 2, 3, 4, 5. Okay, these are the base edges. What is the length? Sir, 40 mm. All of them are 40 millimeters each. Very well. Secondly, if you watch carefully, there is a small dot that I have made. Okay, this is the center of the base, and this point is the pinnacle or the apex. The distance between these 2 points is 70 millimeters, also known as axis, resting on one of the corners of base on HP. Okay, any one corner you can choose, and the entire solid is resting on this corner, something of this sort, which essentially means that the remaining 4 corners will be up in the air. The edge opposite to the corner is parallel to and 45 mm above HP. It is parallel to HP. At the same time, it is at a height of 45 millimeters. That's what has been given in the question. And is parallel to VP. So many constraints. It is parallel to HP. Okay. It is at a certain height, 45 mm above HP. Okay. Now it is also parallel to VP. Let's read further. Any more conditions? Draw the projection when the apex is nearer to the VP. So many things are there. Now the apex also happens to be nearer to the VP. There are so many damn conditions given in the question, but still we can crack it. Don't worry. Let me take you to the solution, and here we go. Let's start. That's the pentagonal pyramid I am talking about. The base is 40 mm. All of these sides are 40 millimeters each. The height is 70 millimeters. If you want to take a look, let me just show this to you. This from the apex, if you make this line which connects it with the center, this is 70 millimeters. Secondly, there are plenty of conditions which have been given. Okay, let me discuss them one by one. First of all, the condition is resting on one of the corners of base on HP. That is the first condition. Resting on a corner on HP. The edge opposite to this corner. Okay. The opposite edge of the corner is at a height of 45 mm. Also, it is parallel to HP. Right? Okay. Draw the projection when the apex is nearer to the VP. Apex is nearer. So, apex is nearer. Please remember. One more thing that you should keep in mind, that this edge is parallel to VP. Edge is parallel to VP. Okay. So these 2 points basically are concerned with the edge, and this point is concerned with the corner. Now we can get going with the solution, but before that, let me switch on the camera so that I can give you a good perspective as to how the object has been really kept. This can really help you Here we go. Let me switch to a different mode. Here we go. थोड़ा जुगाड़ करते हैं, 1 मिनट रुको. ये मेरा writing pad है. Let me make this as my vertical plane. And by the way, this entire video that you're watching right now is also available in Hindi on my second channel, BTech Plus. You can watch it. Okay. And that's the pentagonal pyramid. Let's hope that my phone stays stable in this position. So this is what we are seeing right now. That's a pentagonal pyramid. The base is pentagonal in shape. That is the center of the base, which connects with the top. That is the apex. Okay. How many triangular faces are there? Sir, 1, 2, 3, 4, and 5. Okay, so far so good. Now, it has been given in the question that it is resting on a corner on HP. Let me switch to a different mode. Here it is. Resting on a corner on HP, isn't it? Okay. And read the second condition also. The opposite edge to that corner is at a height of 45 mm above the HP. So let me show you in the demonstration how these two conditions work. Here we go. Let's say that this corner always stays in contact with the ground or with the horizontal plane. Okay, so this is going to be something of this sort. The remaining four corners, let's say these four corners are up in the air. Where one more thing that you should keep in mind, if you watch, let me take this. This is the corner and the opposite edge to this corner is here. This is that opposite edge. This opposite edge is at a height of 45 millimeters, which has been given in the question. Okay. So this is exactly what you guys need to implement. This opposite edge is at a certain height. Now, you guys are watching this from the front. So there is an edge over here, which would look like a point, but there is actually an edge. Let me turn it slightly so that you guys can see it. This is an edge, but when you look at it from the front, it looks like a point. This is going to be your step number 2. In the third step, again, a condition has been imposed, and that says that it is parallel to VP. This is parallel to VP. Please let me know, what is the state of this edge right now? Is it parallel to HP or not? Yes, sir, it is parallel to HP. You can see this. It is parallel to HP, but it is perpendicular to VP. Okay, if I can just extend this in the backward direction, it is going to cut this vertical plane and make an angle of 90 degrees. Let me show this to you. This edge. Let me keep it like this. Will it stay like this? Yes. This edge right now is parallel to the horizontal plane, parallel to the ground basically. If you extend it in the backward direction, you'll realize, it will cut the vertical plane somewhere here and make an angle of 90 degrees. So you need to make sure that it stays parallel to VP. So this parallelism can be ensured in 2 ways. Either you can turn it like this, or you can turn it in this fashion. That means these two conditions can be stated as apex nearer the VP, apex away from the VP. Okay, so these are the two conditions basically. So take a look now. We are not exactly in the front view. I have shifted it. So step number 1, we are going to simply keep it like this. We are going to start by creating the top view first. Okay, and then the front view in this fashion. I hope you are getting this right. In step number 2, we'll do it like this. We are going to recreate the front view from step 1 into step 2 using this height of 45 millimeters, this edge over here, which remains parallel to HP. In step number 3, it has been clearly said in the question that apex is nearer to the VP. So if apex is nearer to the VP, then the condition is like this. Apex is nearer to the VP. And if I change the question, if I write, draw the projection when the apex is away from the VP, then this would have been the final case. Step number 3. Okay, so our condition is apex is nearer to the VP. So you have to do it like this. And then you can create the front view, and you can also create the top view. Okay, proper diagrams will be there, don't worry. I'll help you how to make these diagrams in a very civilized manner, don't worry one bit. Right, let's going with the solution, and I think we shall start. Here we go. Mm, no. Let's switch to the solution. Here it is. So first thing is you need to make a pentagon like this. Yes, sir. Done. Uh, where is the center? Sir, center can be found out very easily using intersection of lines. So this is A, and that's the opposite edge. The opposite edge must be having some center. Connect. This is E, and that's the opposite edge. This is BC's center. Join. And these two lines, wherever they intersect, that is the center point. And this center point essentially has to be connected with all of these corners so that they represent the slant edges in the top view. Done. Okay, so dimensioning properly, do it. Now let's take a look at it from the front and make the projector lines. And basically what you see now are these A, B, and C. It's like a straight line, right? So A and its front view, B and E. B is at the front, E is at the back. Similarly, C is at the front, D is at the back, C dash and D dash. Done, sir. No problem. The height of the pyramid happens to be in 70 millimeters. Okay, so this is the axis from here, 70 millimeters, and then you can connect these three edges, that is CO, BO, and AO. Here we go. Done. In step number 2, we are going to recreate this entire step number 1, but there is a certain condition. That certain condition is that this opposite edge, okay, so this is the corner and this is the opposite edge, CD. This CD will now be at a certain height, that is 45 millimeters, right? So let me first of all lock this A dash over here, and then at a certain height, let me make what certain height? 45 millimeter height. Let me make a construction line. Now with A dash and this much as the radius in your compass, and with A dash as the center, you need to cut an arc, and that is going to give you C dash D dash. Join the line. Do it quickly. Now this much as the radius, again A dash as center, cut an arc again. That is the location of the base of the axis, and then with this much as the radius, and with A dash as the center, cut an arc again, and that's B dash E dash for you. Now what's the now axis is at an angle of 90 degree with respect to the base. So you need to make an axis like this over here. Okay, you can do this very easily using your mini drafter. Keep it over here in this position, and then lock the screw as always, and then draw a line like this. Can you do this? Yes, sir, we can. It's very easy. And then you need to again make these lines. So damn easy. Now what? Sir, let's take a look at it from the top. Draw the projector lines, and from over here also. Take a look at the intersection points. A, that's the location for A. Okay. Then E, that's the location for E. This way you can make this entire top view. If you watch carefully, it appears like a line, although we know very well that since there are 3 corners involved, it will make a triangle. So this line is, or this triangle is clearly visible from the top. That's why you see this triangle. Okay, O, C, D, O, C dash, D dash, and these 2 triangles are also visible. What is not visible is a hidden feature which can be represented using dashed lines like this: A and E, A and B, and then A and O. Let me zoom in. Okay, this also is a dashed line, right? Don't worry, I'm going to make the construction stuff very lighter in the final slide. Make sure that you are drawing all of these projector lines very, very light, 3H or 4H pencil preferably. Okay, sir. Now that is done. How do we proceed now? So where are we? Let me switch on the camera again. Okay. Switched on. Camera mode. Looking nice. Okay, where is the object? Here it is. So what have we done so far? Sir, what we've done is basically we started with this as the step number 1. This was our step number 2. Okay, in step number 2 we gave this edge 45 mm height above HP. In step number 3 we will rotate it until this edge becomes parallel to the vertical plane. Now you can see this edge will become parallel to this vertical plane. Vertical plane is behind, right? Okay, so this is what needs to be done. This is going to be our step number 3, right? Let me take you back to the slide mode. Here it is. Now in step number 3 we are going to recreate this over here, but rotating it at an angle of 90 degree in the clockwise sense. This was step number 2. Agreed or not? Let me show this once again. Sir, yes sir, this was step number 2. This was step number 2. Now you need to recreate this. Apex is nearer the VP. Okay, just a sec. This is the vertical plane. Let me make this setup again. As I said, it is a Jugadu setup. Step number 1, step number 2. Now the apex is nearer the VP. Okay, I hope you get this. And this is going to be your final front view, and that is going to be your final top view. Okay, so in step number 2, step number 1, step number 2, this was the top view of step number 2, isn't it? The 3 triangles are visible. You can see this in the slide also. The 3 triangles are visible. Triangular faces are visible, to be very precise. Now we are going to rotate this, and now you can see this edge over here. This should have had 3 hands. This edge over here becomes now parallel to the vertical plane. The vertical plane is here. This is the vertical plane, right? My writing pad is the vertical plane. So in this condition, you need to make the final front and the final top view. Okay, now step 2, rotate it by 90 degree in the clockwise sense. For step 3, in step 3, making the edge, this edge parallel to the vertical plane. Let's do it. Here we go. What is the first thing that you will do? You have to recreate. Okay, so there are certain measurements that you need to do. Starting with, can you make this rectangle again in this step 3, but rotate it by an angle of 90 degree in the clockwise sense? Do it. I don't give a damn how much these distances are. Just make this rectangle. Create it at an angle of, or create it by rotating it 90 degree in the clockwise sense. Done. Then you need to find this point O dash. So it is right at the center over here. That is going to be O dash. Locate it. I'll explain how all the points have been obtained. Don't worry. Let's say we are talking about this point. So if it has been rotated, this point, let's say, is 1. So over here, we are going to have this 1 as that point. Okay, so from 1 to E, you can take this radius, and using 1 as center, you can cut an arc. This is going to become E. In the same fashion, all the remaining points can be obtained. I'm sure you now have a fair idea as to how these points can be obtained. You have to copy the same figure over here and now bring all the points upwards, and from here to the right hand side, you just need to find the intersection points. This is for O, this is for O dash, and that's O dash. In the same fashion, C and D are going to be along this line. Where is C? Here it is. Where is D? Here it is. Okay, as I told you, this is rather easy. What you finally are going to see is something of this sort. Let me show you the original, the realistic diagram. Okay. Just a sec. Step 1, step 2, step 3. This is what you are going to see finally in the front view, and that is what we have drawn. Can you see this pentagon shape? Yes sir, we can see the pentagon shape. Okay, here it is. One sec. You can see the pentagon shape. Can you see this triangular face also? Some portion, apparent portion of the triangular face. Not some, but yeah, apparent portion. This is that triangular face. Whatever you can see directly, you've made it. Now, the features which are hidden, can be drawn using dashed line. So these are those dashed lines. And the problem is finished now. It's finished. Penny गिर गया बताओ. Chalo. Anyway, so that was the solution. And as far as the construction work is concerned, please make sure that the projector lines stay very, very light. Use a 3H or a 4H pencil, right? This is how the final solution looks. Thank you. Okay, so this is going to be the final problem, final question from this question paper of University of Mumbai, engineering drawing. Here we go. The problem is going to be very, very interesting. I want all of you to have a look at this. Here it is. Question number 4. And by the way, this is of 20 marks. This is crazy. The maximum marks that you can achieve is 60. Out of which this single question can literally fetch you 20 marks, and I can show you how. Okay, it's not that difficult. I mean, you can do this in the next 30 to 40 minutes. It's going to take some time. Okay, you've got to be very careful, you've got to be patient, and you have to maintain accuracy, right? Along with very good pencil work, dimensioning, and all that stuff. Let's read this. Figure shows a pictorial view of an object. Where is that figure? Here it is. I'll come to it. Don't worry. Okay. We'll be discussing its features. What you need to create is the sectional front view along sectional plane AA. Then the top view and then the left hand side view. Please have a look at this. What do you see over here? This is a line which has been made, which sort of acts as a section plane. So just try to assume that there is a cutting plane which is passing through the center of the object. This line literally acts as a symmetrical line which is actually passing through the center of the object. Then remove the front portion of it, and then whatever you see, that is your sectional front view. Okay, whatever part of the cutting plane or whatever part of the section plane comes into contact with the solid, that is exactly where you need to do the hatching at an angle of 45 degrees. I'll demonstrate everything to you. Don't worry. In the next 20 to 25 minutes, we will cover the entire problem. The one issue that I have with this problem is whenever we do section, either we go for a full section or we go for a half section. Here, if you watch carefully, you are putting the section plane along this line and it stops right here. That means more than half, or you can also say less than full. When you do the full section, half of the object is removed from the front, obviously. If you do the half section, that means you stop here. Then 1/4 of the object is taken out. This is a very common practice. Okay. Here, I mean, there are certain issues which I have with this problem. I'm assuming that they have gone for full section, and based on full section, I'll be creating the sectional front view. It would be better if I can just show you the 3D representation of the object so that you can get going with the problem, okay, in a quick way. Anyway, do remember, whenever you encounter such problems of orthographic projection or sectional orthographic, the most difficult phase is the starting phase. When you begin, once you go beyond that, things start getting easier for you. The guidelines are going to help you, and I'll show you how those guidelines can be made. Okay, let me take you to AutoCAD and let me just show you the 3D representation of the object. Take a look. This is going to be fun. Here it is. Okay, this is the pictorial representation which was given to you. Although in the virtual environment, I can do anything with this pictorial representation. Okay, I can move it sideways, I can rotate it about the z-axis and so on. This over here is what is known as a rib. This over here is what is known as a rib. Why have they been provided? The reason being very simple. They actually provide strength to the mechanical component. This is a mechanical or a machine component, you can say, and these ribs are welded over here. Okay, so this is a case of fabrication, you can say. If you want to simply make a mold and then liquid metal poured into it, and then you can do the casting also. Okay, you can pour the liquid plastic also, and then you can make the casting. That can be done, no problem. So that's the object. This is how it looks, and please note that there is a tube over here, and this tube, the inside diameter is 30, the outside diameter is 50. The outside diameter is having this height of 30. How much? 30. Whereas this inside diameter is completely penetrating this portion also. You watch, this portion is having a thickness of 10, which essentially means this 30 plus 10 makes the total depth of the inside diameter to be equal to 40. So don't worry, I'll be demonstrating all of these things just to let you know how the object has been put up. Okay. Now, as far as the sectioning is concerned, you have to go for the section along line AA. This is something that I have already shown. Let me revisit that again. Section has to be done along this line. Let me zoom in. Okay, so the cutting plane has to pass through this section line, you can say, and we are doing a full section over here. Okay, this is what is known as a rib. The thickness is 10, and the section plane which passed through this line, let me make it. Here we go. Section plane, switch it on. The section plane will be parallel to this face over here. Okay, and what I'll do is I'll shift this section plane slightly to the right. Looks nice. Then we increase the size. Here also looks nice. So this is how the object would look. No, this is not the way. The section plane is actually passing through the center, midpoint of the web. So it would be something like this. The web is having a thickness of 10. So this distance over here is going to be 5, and enter. Now you are seeing the section. This is what you need to create. But you need to stick to certain rules. I don't know if you have ever come across this rule set which has been provided by the Bureau of Indian Standard. Let me. This document, this piece of document is very, very important, and it has been recommended by the Bureau of Indian Standards. Okay, this is the second revision of SP46 document, and there are certain rules which you guys need to follow. Let me zoom in, and there are certain rules for sectioning. Here we go, which is in this part or article 10, you can say. Let me take you there. Page number I can recall is 118. Please note, in principle, ribs, fasteners, shaft, spoke are the like are not cut in horizontal longitudinal sections, therefore not to represent in sections. If somehow the section plane passes or cuts along the length or breadth of the rib, then they should not be represented as sections. Although in the software it is representing it, but when you are making the manual drawing, don't do that. Okay, even in the software you can offset the section. Okay, anyway, so please remember, ribs, fastener, shafts, spokes of wheels and the like are not cut in longitudinal sections, therefore not to be represented as sections. So please remember this thumb rule. Okay, so keeping that in mind, what I'll do is I'll remove this rib, remove it here also, and now whatever you see is your sectional front view, and I expect all of you to make this. Okay, let me go on to the front view, and that's the sectional view. Sectional front view. Please have a careful look over here. Outer diameter 50, inner diameter 30. The depth with respect to the outer diameter, this is going to be 30, I guess. Okay, we will do it with complete dimensions, don't worry. And here the depth is 40. You can see this again. Okay, I've already taken a picture and I've pasted it in my PowerPoint presentation. And now let us go for the problem. And here it is. First of all, there is something I need to tell you. This is what has been given in the problem description. Please take a screenshot of this. Please. Have you done so? Okay. Now, this is something that I've extracted from the book of machine drawing by late and legendary Dr. N.D. Bhatt, and it's a wonderful book. I have a copy of the book. Pura cover over chadha ke rakha hai maine. It has been very helpful in understanding engineering drawings. This basically is this subject, in fact, machine drawing, is a sequel to engineering drawing. Okay, so if you want to read more about sectioning or sectional orthographic, to refer to this book, chapter number 5, if I'm not wrong. Now, please read the first line. A web or a rib. Let me switch on the highlighter mode. A web or a rib. Whenever you come across a web or a rib, which gets a section, okay, by a cutting plane, or it is cutting it along its length or breadth, don't show it in section. That means what I essentially mean to say, take a look at this figure and take a look at this section over here. This section. And you're watching it, right? You're watching it from here. That's the arrow. Don't do the section here. Avoid it. This is a widely used practice. Okay, there is another practice which is not widely used. Here, we do the section. Let me zoom in. We do the section, and the outline is also done with the help of sort of dashed lines. And here the hatching is done by alternate lines. You can see the alternate approach, right? But I strongly recommend you to follow this approach. Done. Rule set. Now let's go ahead and let us try to work out the dimensions of the object. Have a careful look. Try to work out what is the maximum length. Sir, from left to right, it's 180. Very nice. What is the maximum width? Sir, it's 90. What is the maximum height along the z-axis? Sir, it is 15 plus 45. That will make it 60. Plus 30. That will make it 90. So the object is having a dimension, maximum dimension of length, that is 180 by 90 by 90. In the front view, you'll make a box. How much? So 180, 190. In the top view, again, this is going to be 180 and this is going to be width. Okay, that's the length, that's the height, that's the length, that's the width, which again happens to be 90. And the side view, well, we are going to do that eventually, don't worry. So start by making two boxes. And please make sure this distance, let's take it as 10 millimeters. This also has 10 millimeters. This also has 10 millimeters. Can you do this? I'm sure you can. Now, let us worry about the box in the side view. Produce lines through these 2 points. Rotate them at an angle of 45 degrees. This can essentially be done using a drafter, a mini drafter. Produce in the upward direction. Produce lines through these 2 corners to the right. And there you go. This is the space which is meant for left hand side view. This space is for the front view. What? Sectional front view. And here, that's the space for top view. Done. Let's get going. As I told you in the lecture today, that we are going to be making some guidelines and they are going to help us create all the views. In fact, we are going to start off first of all by making the center lines. Okay, this is a center and the lines passing through the center, what you call the center lines. How do you make them? So this center, this is really a center of 90 is at 45. Along this length over here, this is going to be how much? This is going to be half of 180 is 90. Simple. So that's how we do it. Again, let me reiterate. This is 90. This is 45. And then you can extend this center line in the front view also. Now the entire object is symmetrical about a vertical plane, about a plane passing through the center like this. Okay, the entire object is symmetrical and let's take the advantage of it. Very well. My PC is getting slow these days. I need to make an investment very, very soon rather than later. Okay, now take a look. Sir, if this is the center, there are 2 circles, sort of rings. Inner one is having a diameter of 30, while the outer one is having a diameter of 50. So what we'll do is we'll make 2 extreme lines. This is the inner one, 30 diameter. We'll make a circle, don't worry. I'm just interested in making the guidelines right now, which in fact will act as projectors. 15, 15. Similarly, the outer circle, 50 diameter, 25 to the right, 25 to the left. Okay. These 2 edges, this way. All the guidelines that I'm making right now should be done with the help of a very light pencil, 4H pencil, very grayish stuff. And then if you watch this, there is an edge Again, there is an edge here also. There is an edge here also. So these edges are spaced 10 mm, 30 mm, 10 mm. And from the right also 10 mm, 30 mm, 10 mm. Let us do this at a distance of 10, then from here at a distance of 30, from here at a distance of 10 again. I hope you all are able to do this. Okay. Problem will be finished in the next 10 minutes. Don't worry. Now take a look at these centers. These centers. These are the centers I'm talking about. Sir, how did you locate this distance? This distance, by the way, is 20, which has been given in the problem. Here it is. And if you want, then I can zoom into this figure. Sir, this in totality is 90. This is 50. 90 minus 50 will give us 40. So half of 40, that is 20, is over here. And the remaining half is here. Now you can understand, if this is 20, this also has got to be 20. Okay, you can locate this very easily. Let me reiterate. What you need to do is, from here, you just need to make a line, construction line like this. And from here, again at a distance of 20, make this line. The intersection will give you, you don't have to make this much big line. A smaller line will do the job. Smaller line will do the job. You just need the intersection point. Okay. Now, how do you proceed from here? What we can do is, we can make this rib. If you see carefully, this rib is passing through the center line. This is the center line. This is the center line I'm talking about. The width is 10. So 5 above, 5 below. 5 above, 5 below. Done. Rib work over. What is the next step? In the next step, what we'll do is, take a look. This. One more guideline. Here also. What is this distance? Sir, this distance is 10 millimeters. So from here, 10 millimeters, and from here, 10 millimeters. Done. So all the guidelines have been made. You just need to make sure that you've got an edge pencil. Okay. And now you start making the final top view. This top view approach is going to be very easy for you. Okay. You could have also begun with the front view. That is your choice. I felt that if we start by top view, then we can very easily create the front view. One more thing that I want all of you to note. Whenever you make these center lines, this is the center for both the circles. Make a plus, right? Make a plus first of all, and then make these chain lines. Okay, please follow this. Starting with the circle. No. We are not going to start with the circle. Rather, we are going to start with this point. Can you see this point? 10, 30, 10. Okay. 10 here. 10, 30, 10. 10 in this direction. 10, 30, 10. What we are interested in is this very point. Okay. So this point. And here also, from the right also, the same stuff is going to happen. This is 10. 10, 10. Do it. Now move in this direction. And from here to the right, just do it. And now in this direction. And in this direction. There we go. Finish it off. Finish it off. Done, sir. Now what? Now you can create these circles. The inner circle is having a radius of 30. No, not the radius. Inner circle is having a diameter 30. The radius will be half of it. The outer circle is having a diameter of 50. 30 dia, 50 dia. Sir, what about these holes? These holes are having a diameter of 10. So make them. Done. Very easy. Now make the rib. Can you see the rib? From the top, the rib would apparently look like this. Make it dark. Okay. This 2 points. Here we go. These 2 points. Similarly, there are going to be 2 points over here when the rib joins the topmost point. Like this. Done, sir. Very easy. Now what? Now what we'll do is, we are interested in making the hidden dashed lines. Dashed lines are used to represent the hidden edges. Where are those hidden edges? Sir, there is an hidden edge over here which goes right till the back. Then there is an hidden edge here and here. Then there is an hidden edge here. So there are plenty of hidden edges. Now, first at a distance of 10, there is this hidden edge. Done. Right now, I'm making these dashed lines using a red color. Okay. because black over black was, it was getting a bit difficult to see them, observe them. So I'll change the color in the final view. Don't worry. Then travel a distance of 30. You end up here again. And then if you watch, students, there is a solid edge over here. Right below this edge, there is one more edge which extends in this direction until you travel a distance of 90 millimeters. So some portion of this edge is falling just below this solid edge. So leaving that portion, that means I'm talking about this portion. The remaining portion is hidden. That means you have to use a dashed line like this. Done. The same stuff over to the right hand side. Whatever has been done to the left has to be done to the right hand side. Done. 20 minutes are over. I want to finish this as soon as possible. And now, this very point. Okay. Please see this very point. Behind also you will have the same point. Come forward. And then you'll also learn how to encounter these curves, sort of arcs, right? Then this over here. Then this over here. So let's make this. Just a sec. This way. The same in the back portion also. And then you can finish it. Now you can see this. There was actually no point in making this hidden feature because it is falling exactly below the solid edge, right? But still some portion of the hidden edge is visible here. This portion, that's visible. Okay, so far so good. Now top view is over. We are now interested in making the front view. How do you do that? And here also you need to make the sectional front view. I've already taken a picture. Take a look. Okay, let me switch it off for the moment. Let me make the guideline. So the first guideline is, if you watch carefully, this distance has been given as 5, although it looks as if it is 10. Okay, if this is 5, this is the one at the bottom is going to be 10. So right from the bottommost edge, you have to travel a distance of 10 and then 5. Why is this 10? The reason being very simple. This in totality is 15, out of which this is 5. So the remaining is 10. So from here, bottommost edge, 10 and then 5, right? Okay, sir. Then at a distance of 45. And then once you reach here, we are right now along this line. Okay, then we need to travel below by a distance of 10 millimeters. So make another guideline. I'm calling them guidelines because they guide you towards creating the front top views. These are rather projectors. Okay, please remember. So far so good. Now let us start by doing the construction. Please remember, this is what you saw, right? If you can create a picture in your mind of the object and then cut through to your object to the full section, remove the front portion, this is what you see, right? This is what you see. Then this portion over here, please note this sort of inverted U. It's not just at the front, it has been extruded towards the back by a distance of 90 millimeters. Okay, wherever you do the section, you are going to see this. Wherever you do the section, here also, whatever you see at the front, wherever you do the section, this is the profile that you will see. Okay, so from here, let me go above this way. And how did you make this, sir? How did you make this arc? It's very simple. Let me just brief you on this. Let's say you've got a corner, right? And you want to smoothen out this corner having a radius of 5 millimeters, let's say. How do you do this? It's very simple. From here at a distance of 5, make a line very, very light. From here in the downward direction, again make a line very, very light. This is the intersection point. Now with the help of a compass, rotate in this way. The radius is 5 and you are basically making a fillet over here. In AutoCAD we call it a fillet. It's very easy. You just need to select the edges and provide the radius, and voila, what you have is a smoothened out corner. Okay, and let's proceed now. This is what we've made. Now, as far as this portion is concerned, this is what I'm talking about, right? This much portion will be hatched. We'll come to that. Let me make this. As I told you, this is the outermost diameter, which is 50. This has a depth of 30. You can relate to this. Secondly, the innermost diameter is 30. And here the depth is more. Here the depth is 30 plus 10, which is 40. This much 30 and plus this much also. As I told you, this is the region. Okay. It is penetrating this plate also. You can say this. Done. Okay. Now what's up? Now we are almost done. Let me make, as I told you, ribs. Ribs are special. Don't consider them in the section. Okay. Here we go. These are the ribs. And now you can do the hatching this way. Wonderful. Let's go for the side view. Side view is very easy. What you see initially is this. Do it. Okay, I need to produce lines. Rotate them at 45 degrees. Produce them in the upward direction. And the first step is this. Center line. Done. Can you relate? Yes, sir. Secondly, there is an hidden edge 5 mm below. There is an edge just behind this. Behind there is an edge. That hidden edge. These guidelines are helping you. Again, we are using these dashed lines. Very easy. Now what's there are these holes also. There are these holes. So one hole starts here. This is one hole, and then this is another hole. Okay, so make them quickly. Done. Let me zoom into this. Can you see the holes? Dashed lines. Right. Hidden feature. Now you can make the rib. Very simple. This rib. You are now watching it from over here, left hand side. Why? Done. Now what's now you can make this. This line, and then you can simply close it from both the side. Done. What about this tube? First of all, let me make it like this. The outer diameter, how much is this? This is 50, and this depth, as I told you, this is 30. I could have brought lines from over here also, but it was getting crowded, and from here also the drawing was getting crowded, so I avoided it. This is having more depth. Diameter is less. The diameter is 30. Okay, please remember this was 50, 30, and now here this is going to be 30, and the depth is more, which is 40. Done. Your drawing is done. One more thing is left. There is an edge here, isn't it? That has to be made. Can you see this? Can you see the edge? Okay, right behind this there is an edge. So yeah, this finishes our problem. 27 minutes and 38 seconds. It's almost done. So please listen me out completely. These videos take a lot of time and effort to create. Okay, so whenever you see any teacher working for all of you, making such content, do give them respect in the form of liking the video, sharing with as many friends as you can, so that they can also benefit, because these things take a lot of time. And by the way, the entire PDF will be made available on my application. It's free. You can have a look at the PDF, no problem whatsoever. It's just that you need to download the application. Okay, download the app, go to the engineering drawing course, and inside that you'll find a special folder for Mumbai University. Inside that folder you're going to find the PDF of this question paper 2022. Right, so guys, that was all from my side for today, and we'll be solving many more question papers. Recently a student contacted me for solving the 2023 paper of the Mumbai University. So if you have the question paper, you can mail it to me. My email ID is manas2787 manas2787@gmail.com. Okay, please send me a good quality PDF copy of the question paper, and I'll make a solution on it. Any question paper, any previous year question paper, and in fact any student watching this video from any other university across India can send me their question papers. I'll definitely make a video on their papers as well. Thank you very much. This is Manas Patnaik signing off. Take care. Have a nice day. टेक केयर.